Hey guys. All right, today we are talking about multiple representations of linear functions. Our objective for today, we are using a table of values to graph a linear relationship. Make sure you write down everything you see and everything that I write down. So first of all, what is a linear relationship? Well, that is a relationship between two variables. Usually you're going to see x and y. And when graphed, it appears to be linear. Linear is just a fancy word saying that when you graph it, it forms a line, like what you see below. Now, this can be represented by an equation containing variables, again, x and y. All right, so I want you to look at this table and this graph right here. You don't have to write all of this, I just want you to look at it. Now keep in mind, whenever we talked about ordered pairs, we always have x and y, and we see it in this form. So all you're going to do is take your x and your y values on your table, and you're just going to plot the points. So see here we have the number 0, and we have 2. 0 is x, 2 is y. So that would be the point 0, 2. And then over here on the graph, we would go to 0, 2. Next we have 2, 6. We would plot 2, 6 on the graph, and we would go from there to create a line. All right, here are the steps for graphing a linear function. We want to substitute the x value into the equation and solve for y. We will be finding the equation from the word problem, so you are going to have to create that on your own. Step 2, we want to fill in the y values on the table. Step 3, we want to plot the points on the coordinate plane in order. And step 4, we want to check to make sure the points connect to make a straight line. Again, this picture right here you do not have to copy, but I do want you to notice that for the x and y values, we did have this equation right here. So y equals 2x plus 1. Right here, this x is negative 2. So we took that negative 2, plugged it in for x, so we got 2 times negative 2 plus 1. And when you solve that, it equals negative 3. As you can see on this coordinate plane here, negative 2, negative 3 is this point right here. Negative 1 would come next, and so on. Now, you don't have to plot every point that would be on that line. You just have to point a few, and then you can use a ruler to create the rest of the line from there. And I'll show you what I mean in our next example. All right, example 1 says a movie rental service charges $1.50 per day for a late movie. All right, the first thing that we want to do here is we want to identify the independent variable and dependent variable. Remember, independent is your input, dependent is your output. And then remember that independent is your x value, dependent is your y value. And I'm going to go ahead and fill those in on the table. Now, think about independent and dependent like cause and effect. So our independent variable, that's like the cause. The dependent would be the effect of that. So if you were to rent a movie, the number of days late, that is going to affect how much you are charged. So the cause, the independent, would be the number of days. And then our dependent, which would be the effect, that would be the actual charge. All right, now that we have that figured out, we want to start filling in values on the table. Now, you're used to seeing some x values already there, but we don't have any, so we have to create our own. Now, I'm just going to tell you right now, I love the number 0. That's my favorite thing to start with in these situations. So let's say that x is 0, okay? But what am I plugging x into? Well, I need to figure out what my equation's going to be. So it charges $1.50 per day. That means that would be $1.50 times x. And that's going to equal y. So y equals $1.50 times x. So if the movie was 0 days late, we would plug in a 0 for x. 0 times $1.50 is just 0, which makes sense. If your movie is not late, you are not going to get charged for it. Now, let's say that the movie is 1 day late. So if we took y equals $1.50 times 1, well, $1.50 times 1 would just be $1.50. So y would equal $1.50. Now what if it was 2 days late? Then we are going to take y equals 150x and we're going to plug in the number 2. $1.50 times 2 would be 3, so y would equal 3. Alright, I am going to stick with these 3 points right here. Now I want to graph it. So I'm going to look at all of my ordered pairs and I'm going to plot those on the coordinate plane. So my first one, I have 0, 0. So I'm going to plot that right here. Then I have 1 and 1.50 or 1.5. So I'm going to go right 1 and then I'm going to go up 1.5 because remember 1.50 is 1.5. So that's going to be about right here. Then I have 2, 3. So I'm going to go over 2 and I'm going to go up 3. Notice that these points are in a line. Now, once you get here, all you have to do is take a ruler, line it up, and then you can just draw your line the rest of the way. Alright, my line is not perfect, but you get the idea. Now, at the end of these lines, you want to make sure you put arrows because this line is infinite. It goes on and on forever, so make sure you have your arrows at the end of the line. Alright, example 2. Admission to the carnival is $2 and each ride is 50 cents. Alright, let's identify the independent and dependent variables. Alright, remember independent is x, dependent is y. And I'm going to go ahead and fill that in on the table. Alright, so we are looking for the cost in this situation and we want to see what is going to affect that cost. Well, however many rides you choose, that is going to affect the total cost. So we know that our independent variable, that would be the number of rides. And then the effect of that would be the total cost. So now that we've identified that, let's go ahead and create our equation so that we know what we're actually going to plug x into. Alright, each ride is 50 cents. Let's start with that. And remember, it's always going to start with y equals. So we have 50 cents per ride. So the ride would be x because we don't know how many rides there are going to be. So it would be 50 cents times the number of rides, which is 0.50 times x. Now, admission to the carnival is $2. So no matter how many rides you ride, you're going to have to add $2 to that because you had to pay $2 to get in. So our equation, we have y equals 0.50x plus 2. Alright, now we want to create some x values and we want to find our y values. Just like I did in the last problem, I'm going to start with 0 because 0 is so easy to work with. So, if I have y equals 0.50x plus 2, I'm going to plug 0 in. 0.50 times 0 is just 0. So y just equals 2. Alright, let's use the number 1. So if y equals 0.50x, I'm going to do 0.50 times 1 plus 2. So that would be 0.50 plus 2, which would be 2.50. Alright, let's say we use 2 for x and ride 2 rides. So y equals 0.50 times 2, and then we're going to add that 2. So y equals 1 plus 2, and y equals 3. Now we want to graph this. So our first point would be 0, 2. So I'm going to come over here at the origin. X is 0, so I do not move left or right, and then I move up 2. So there's our first point. Now we have the point 1 and 2.50. So I am going to go right 1 and then up to 2.50. Now my next point is 2, 3. So I'm going to go to 2, 3, plot my point, and then from here we can see that these points are forming a line. We can use our ruler and create a line from there. And again, this line is not perfect. All right, make sure you put your arrows at the end of the line to show that it is in fact continuous. All right, now it's time for you to try. I want you to do this problem. Don't forget to create your equation, identify the input and output, fill in your table, and then plot your points from there. Make sure you have recorded everything and that your notes will be ready to grade in class. Have a wonderful evening.